as we heard on the keynote already, there is a trend that has been started previously, earlier, with quantified self, with people wanting to know more about the data that can be generated by their usage and what people are doing with it. And this started like very early on. So this is not something new. Like in the old days, this used to be going, keeping a logbook of calories or stuff you ate or stuff you did during the day. But then, of course, as technology progressed, then, of course, we had more and more tools to do this in a better and better way, which was less intrusive and made it easier. So, we now have step counters. Now, I mean, like in 2013, so we have moved beyond that, hopefully by now. And, there is activity monitors, which are doing a more generic type of activity detection, whether you are walking, whether you're cycling, whether you're running. So there is, a growth and an expansion in sort of what kind of activities we can detect and what we can log. And it is a market that is exploding. So if you take a look at it, from the papers, from all the news sources, there are huge, huge predictions. Everybody is all over the board how many this will sell and how many of them will there be. So millions of devices sold. Everybody plans on buying one. And, overall, as they say, 500 million people seeking for a new device in the category. So it is a very, very hot market. And if you take a look at Fitbit and all the other manufacturers that are always doing activity trackers, but not just activity trackers, but all sorts of monitoring equipment which is related to wearables, then you'll see that it's a huge market. Now, the thing that we have been doing is heart rate monitoring. There is a reason for that. It is the single most important biometric indicator. Can you tell me why? Anybody? Guesses? No? How do you check if somebody's alive? So hopefully you will not use our sensor for that. So we hope that it doesn't get to the point where you already need to decide it. But the point is that heart rate is something that is literally present in every measurement that you make, whether it's your condition, your stress levels, your activity levels, your physical exercise, heat, cold, everything, literally everything is in some way reflected in your heart rate. And it's not just the heart rate. We say heart rate as a number, but it's actually more like a signal. So, it goes up and down, the flow of the blood. And the shape of that flow also tells you a whole lot of things, even though the number is the same. So you count the number of peaks and we call that heart rate, but there is a lot more information hidden in that. So we kind of already have a solution for that, right? So we have chest belts, and that sort of worked, but there is several problems with that. So they are invasive. So if you put down one, it takes a while. You cannot do that in 5 seconds. You need to dress, undress, prepare. They have to be in a very specific position. There is a problem if you are using them overnight, so you sleep, you roll over, they can get uncomfortable, then the question of sweat, etc. So there is a lot of problems with chest straps. And therefore, there has been a huge surge in research when it comes to optical heart rate monitoring. It's just easier to set up. You literally have a watch on your hand, and that's it. But we are not really tied to the wrist, so you can put this in anything that you wear. So everywhere there is skin contact, it can work. Some places are better, where there is more blood, it's better. But generally speaking, you can have this in a hat, you can have it in a wristband, you can have it, in your shirt, anywhere that has skin contact. So that is the good thing there, that we have a lot more freedom to apply this technology too. So we embarked on making this little device here, which is the PulseOn heart rate measuring. So as said, as far as the science goes, it's actually pretty simple. Whenever there is a heartbeat, the number of blood cells or amount of blood in the veins and arteries change. And we know that the blood has a certain optical kind of a characteristic to it. So you shine light on it, and the amount of blood makes more or less light pass through it. So if we have an illumination, like a source of a LED, and then we have a photodiode there that detects this, then we can see as the blood flow changes, with every heartbeat, we see the amounts of light being reflected change just the same way. So basically, you get a nice little beat signal, which is recorded with a signal, and from this you can deduce the heart rate, and as I said, many other informations as well. So we had the very simple premise: lose the strap, keep the accuracy, and gain the insight. So I said it's just the physical convenience on one side, but at the same time we want to keep the accuracy. So of course, detecting electrical signals is a lot more precise indicator of what's going on in the heart, not necessarily the whole system, the body, but the heart definitely. So we would want to keep that and also gain the insight that gives us. So for PulseOn, we went two ways. One, create the actual device. This is to show, because this is a startup, that we actually can do this. So it's not something that is written on a paper and then we want to sell, but rather we can make a device, and we did, that can successfully monitor heart rate in a very, very precise manner. At the same time, I said, because it's not a huge company, there is a little heart rate module that we license, which is in this device, which we can then integrate to anybody interested. So we actually have a little thingy here at the end of this cable. You probably see the cable, not as much the thing on the end. It's very small. And that's what goes into all these smartwatches and activity trackers and everything basically that measures heart rate monitoring nowadays. So we hope to see more of that in the future. But there are, of course, some constraints. There are physical constraints, how big this can get, that also defines where you can put it on the body. There is a limit with the batteries, how much power you use. You want more precision, but then there is a trade-off. You keep on the devices more of the time. You do more readings. You shine more light. That all just increases your power footprint, and that's not really helping. At the same time, you want to be, have a flexible architecture that allows you to change based on demand. So, what kind of device we are making? Is it a smartwatch which already has 10,000 other things in it, or is it a dedicated device where precision is key? And all of this, in the end, reflects in the complexity and cost of the thing. So, we went for a couple design. On one side, this PulseOn device is running on a very, very modest Cortex-M3 MCU. So it's not going to run Qt on its own, unfortunately. But on the flip side, it gives us a lot of flexibility when it comes to battery power and form factor. So we could cram a whole lot of functionality and in a form factor that we want to without sacrificing or going for really bulky smartwatch type of approaches. At the same time, there is a need for a backend. So we need to do the heavy lifting somewhere, the processing, and people need to interact with this device somehow. Yes, there is a small screen, but then you realize that it's a different thing looking at a 4, 5, 6-inch smartphone display and looking at a small, basically half-inch display on the device. So there was a need for that. And finally, we need to make a bridge, how you can log, analyze, and all that, and just make best use of all that data that you are creating. And therefore, that application was created with Qt. So the other side is working pretty nicely. So we had everything set down. The science is clear. This is a very verified way of detecting heart rate, no problems. The business model is clear. We both have a device of our own and have a licensing model for all those interested. And we chose Qt as a way to create the backend that does both the UI and the heavy lifting as far as the companion application goes. And that's not just for the display. I said it does actually the calculations as well. And finally, it's actually good for both R&D and development, deployment use. This is something that is I think comes up far too rarely, that the R&D teams can use the same software as the final deployment. It's not just a mock-up and then you re-implement the whole thing from scratch. So the reuse of code is actually very, very good when you're using Qt, and that was something we were really very happy about. Showstopper number 1 in the science part. So that's all nice when you're standing still, and that's why you do this in the school books and the academia and all that. But the problem is when you start moving, you run, you're a dynamic system. There is a lot of things that affect the blood flow. So when when you're running, you're swinging your arm. That creates extra forces that force the blood in certain directions. So it's nowhere as near clear the signal that you're getting as you had hoped. So the heavy lifting needs to be there. So obviously, it's not as simple as just having a single LED there. So PulseOn actually has a more complex way of doing that. Different wavelengths penetrate to different depths. So there is an extra lot of complexity, and there is a really, really hard scientific work behind that. So we actually have a university connection. One of the founders is a professor who is specializing in bioengineering. So that's also something that has helped a lot. So it was non-trivial, and that's one thing that you cannot anticipate. And this is super important with wearables. Suddenly, you start with one premise, and then you say, oh, by the way, you need 10 times more CPU power. And I was like, that's good. So that's a huge problem, and not just for the software, right? So we can optimize algorithms and everything, but then especially when you're doing products, then the hardware part is becoming a serious problem, right? So it's not that just, we just put in a 10 times bigger CPU in there, because then that just snowballs the requirements in terms of battery, in terms of everything else. So that the advantage here was that, luckily, because we were offloading all the heavy lifting on the application, then we actually could do a lot of the things on that side, on the smartphone side, and not process every bit of data on the small device itself. So that gives you a lot of freedom. So keep in mind that these requirements change. Of course, we ended up with a slightly different device than we started with, so it has several different LEDs. These different wavelengths penetrate to different depths, as said. So you create more like a radar type of reading of what's going on in the different layers of blood. This filters out also the differences, what happens if it's cold outside, then there is the blood flow, again, is affected by that. If it's cold, if it's warm, the difference, what's happening when you are exercising, when you are sitting still. So there is a lot of that, and this design has helped us a lot. Second, the business case. So, we did our market research, everything, so it was clear. You take a look at the running magazines, you take a look at agencies, they all will tell you the same. Most of the runners are female. The most populous group within that is going to be between the 25 and 35-year-olds. And luckily, these are also the persons who spend most money on accessories. And when you take a look at the market share of smartphones, then Android is the one to go for at 80% of the market share. So we kind of aimed for that group, and just to verify where to go next, we of course added analytics and crash reporting in detail, so that we know that within that subgroup who is next, who is the most interested in using and how they are using our devices. Of course, crash reporting is useful no matter who uses it, but still you want to know what's going on and under what circumstances. So we actually rolled our own. Unfortunately, there is no built-in crash reporting or analytics in Qt itself. So we made a go for it for our own. There were some requirements. So we wanted it to work both on the C++ side and QML. We wanted it to be fairly standalone. REST APIs were okay, so we can make network calls, but we didn't want to include any of the SDKs of various third parties. So there are solutions, Hockey app, Crashlytics, you name it, that do this kind of work, but they would all include their own SDK. The same from Google Analytics. They all have their own SDK, which we didn't want to go for. We wanted to make it safe enough so that we know that the data shuttle cannot be sniffed on, so of course it has to support some sort of encryption of the channel and such. And most importantly, this is again super important on the wearable side, it must support native code. When you ask all these Crashlytics and all the others, do you support native codes? And they will say, yes, of course we support native code. And then, for example, I say, yeah, Java on Android, Objective-C on iOS. And I'm like, not the quite of native code that I was kind of looking at this point. So we need to go lower. So our code is actually on the Bluetooth stack layer. So we don't really get to see much Java there. So it's really just C. And when something crashes at that stage, we need to know. It's not good enough to just get a response that, oh, something in your JNI code somewhere crashed and behind the wall of the library. So we needed something that can go deep enough to provide us with native insight. And we went for our own seed. There is actually going to be a session tomorrow, which is a longer one than this one. This is actually not a 1 hour session as I thought, so I'm running a bit through it. But tomorrow is a session on the crash reporting and analytics and how we implemented it and what were the learnings from that. So if you're interested in detail in how you do analytics and crash reporting, like the actual code and the tech part of it, then tomorrow is the session for it in the afternoon. So back to the premise. This was the business premise. And turns out there is something wrong with this. So we had a number of users already buy this device. We were selling it, so we have a large enough user base, so it's not like 10 people there or friends and family. And it turns out that 70% of the users are male. Okay, so it turns out guys buy devices, gadgets, not a surprise in that way. And median age of users was actually 43 years, so they are not really teenagers. And actually, it turns out that there is a lot of iOS users. So it turned out that there was a thing that our early adopters, so the people who were most interested in this whole trend of logging and analyzing what's happening, all that stuff, were actually a very different target group to what we thought that we were getting at the first place. So it's not the same person who is going to buy the nice shoes, sneakers, as the one who is buying this gadget, right? So there is an overlap, and it's certainly like an accessory. But they're not necessarily the same target group. So when you're going for wearables, make sure that you understand the target audience. That are they willing to actually buy that? Are they willing to wear it? And are they willing to use it? And what circumstances? So it's fiddly, if it's geeky, then you might be looking at the wrong people there. So make sure that you have this from the get-go, so that you don't have to tweak the the thing later on. Now, we had a number of things which were bad at the beginning. So when we started development, this was actually 2 years ago, then we had a number of things missing that we really, really liked to see. They luckily came later to Qt. So first of all, Qt for Android and iOS happened in 5.2 officially. There were tech previews earlier, but that's something that really helped us a lot. Then again, with Bluetooth, there was an evolution. So in 5.3, it appeared in Android. Later on, there was the BTLE version of it in 5.4, with also 5.5 that made it a lot easier to have it working in a nice and consistent manner. And of course, Qt Quick Controls. So when we started, there was no real good story on mobile for Android or any operating system, basically. So we really had to make our own custom UI. So that was also eating a lot of time. So these things are now in there. So we would have done it so much faster if we knew it, or if we could have waited this long. But then, of course, you have to make a device. Then you don't. You always have a next version that has some awesomeness in it, but we didn't have the time to just kind of wait for that. So this is not bad enough. There is a special place, in hell for people who make you write Bluetooth stuff, because the compatibility matrix is really bad. So there is different versions of Android. There is different versions of iOS. There is a combination of Bluetooth, SPP and Bluetooth low energy. Then there is a special option for going for Bluetooth LE heart rate profile. So there is such a mixture of versions of operating systems and the various possibilities of what you have within the Bluetooth specification itself, that this compatibility matrix is a nightmare. So be aware that, if you haven't dealt with Bluetooth, then it might look as like a nice technology, maybe sometimes fussy, but if you're a developer, then, you grow gray really quick. So you have to basically draw a line and say, well, we don't go underneath, I don't know, Android 4.4 or some certain version, depending on what the feature set is that you're looking for, because you just cannot support everything. So there is no way on Bluetooth, unless you have like really too many people in your company, that you can test all these and have something that works consistently. Usually what happens is that you fix one thing or with one particular device. Oh, I fixed it with iPhone, and suddenly it doesn't work with the Nexus. So it's very, very obscure. So it's really something that is very difficult to track and predict, how much time it will take fixing. So, Bluetooth is a messy thing. So keep that in mind. But there were places where Qt really helped us a lot. So remember that switch that we realized that, Android is not our primary platform. So we just scrambled and went for iOS. And it was actually pretty easy recycling most of the code we had already for Qt to just make that build for iOS. So it was really a good experience. We didn't have to write it from scratch, and we didn't have to make too many compromises to have it present on iOS. That was a really good thing. The other thing was that since we were all using Qt throughout the project, so the R&D team who was doing the research on the algorithm, the team who is writing the application, the companion application, they were all using Qt. So it was pretty easy to go back and forth and exchange code, and there was no hard and set wall. It's like, you're using language XYZ, I'm not looking into that, because we have a person who is speaking that single language or looking at that single part of the code. So we had a very little problems with that, which sometimes happens in embedded, that, I'm a front-end guy. I don't know what happens down there. I don't want to touch it, and the other way around. So this is also something that is in large parts mitigated by Qt. The other thing is we actually made a couple of custom solutions. So there is nothing that says that you have to run this on a phone. So, there is Qt for Android, there's Qt for iOS, there is Qt for Linux, and you can run it on a Raspberry Pi as well, this companion application of ours. You can run it on an Edison, like a little board like this. Well, this little metal part is the board. The surrounding is the breakout board there. So, and this actually runs the full application and all the calculations that we need for it. So it's actually very easy to make an embedded device which you just kind of keep wherever you want, in your car, in your surroundings. Doesn't have to have any physical contact with you. And whenever it's in proximity of the device, it automatically downloads all the data available. The device can work on its own for several hours, days even, depending on the use case. So it's a good thing that you can just offload this data into very own small custom solutions. Again, this is something that is possible because we use Qt, which is so easy to move between these platforms. And of course, we use a number of third-party applications and libraries for making these, and it was actually pretty easy to interface with Qt. So I wrote bindings for a lot of components which didn't have prior any kind of Qt API, and it was very easy to wrap them somehow in QML so that they can be used from there. So Now it would be demo time. We are a bit short there, so I hope that I can just show it. So bear with me if this doesn't show up on the first attempt. And let me try and see. Otherwise, you'll have to just come over here after the session and see it in person. So what I have here, and which is giving me some grief now, and I have far too few hands to do it, is basically an application which was written in Qt and using Qt Quick Controls for Android. And the good thing there is that it's actually able to talk to several Bluetooth devices at the same time very nicely. So I can start recording, for example, from my wrist device from the phone, and now I have a ton of data coming in from that. So it's recording the various different wavelengths, it's recording all the sensors, and that's another cool thing there, that I'm also able to tap into the Qt sensor support. So I'm actually able to record all the extra data that I get from the phone itself through Qt, all the APIs that I already have there. So if I go into my little menu of the settings, I can configure all the individual sensors that I have. So for this phone, it detected GPS, accelerometer, gyroscope, magnetometer, and a ton of others, like in total about a dozen sensors that I have in this phone. So nowadays, they come actually with pretty cool sensors, stuff like barometric pressure, temperature, and all these things which can make the research all much better. Because we can collect that data, and as said from the trend at the beginning, that we can use that to refine the research. So we know that what's going on when people are running on high elevations, what's happening when people are running in 40 degrees heat. So it's a very different environment, and therefore there is, of course, physiological implications that we want to take into account. And this is just a very, very convenient and easy way to do that. And as said, because of using Qt, it was actually pretty easy to integrate into our existing solution. So that was like I said, unfortunately, the demo is not cooperating here for the video scan, so you will have to come over if you want to see it in person. But that was the short intro of how we use Qt on wearables. Or rather with a specific wearable, in our case, the heart rate monitoring. But it turned out to be actually a pretty good match, and we are pretty happy that we managed to use it in the ways that we did, and it gave us a lot of flexibility. So if you have any questions regarding either wearables in general, heart rate monitoring, or the use of Qt in the same thing, then just raise your hand and ask. And thank you for the attention.